Pascal's triangle, expanding binomial powers solved problems. Problem 1. Expand x plus y to the power 4. The expansion of x plus y to the power 4 follows the same pattern as the expansion of any binomial power. We have a number of terms which are added together. Each term comprises an integer multiplied by x to some power multiplied by y to some power. We're expanding x plus y to the power 4, and the powers of x and y in each term must always add to 4. 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, and so on. With the terms laid out in the usual fashion, the power of x decreases as we move to the right along the terms, and the power of y increases as we move in that direction. However, the sum of the power of x and y is always 4. The integers in front of each term are called the binomial coefficients, and the values of the binomial coefficients come from Pascal's triangle. And I've shown Pascal's triangle in two different forms, one with the values here on the left, and one with the names here on the right. Each row in Pascal's triangle shows the coefficients for the terms in the expansion of the corresponding power. So for the power 2, where we're expanding x plus y to the power 2, the coefficients have values 1, 2, and 1. And for power 3, they have values 1, 3, 3, 1. The coefficients are calculated by the left-right addition process from values in the previous row. So for x plus y to the power 3, we add 1 and 2 to get 3, 2 and 1 to get 3, and we continue with the 1s at the end. For x plus y to the power 4, we add 1 plus 3 to get 4, 3 plus 3 to get 6, 3 plus 1 to get 4, and we continue with the 1s at the end. On the right, I've shown the names of the coefficients in Pascal's triangle. So for x plus y to the power 4, each coefficient is labelled with 4 to show which row it comes from, or which power we are expanding by. The number at the bottom corresponds to the power of y in the corresponding coefficient. So for the first term, we would have y to the power 0. For the second term, we would have y to the power 1, and so on. So expressed using the names of the coefficients, x plus y to the power 4 looks like 4c0 x to the 4 y to the 0 plus 4c1 x to the 3 y to the 1, and so on. And to expand that numerically, we replace the names of the coefficients with the values of the coefficients, which I have given here. And if we do so, we end up with 1x to the 4 y to the 0 plus 4x to the 3 y to the 1 plus 6x to the 2 y to the 2 plus 4x to the 1 y to the 3 plus 1x to the 0 y to the 4. And we know from the rules of powers that x to the 0 equals 1, y to the 0 equals 1, and we usually write x to the 1 as x and y to the 1 as y. Then the expression in the previous line reduces to x to the 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4. Problem 2. Expand a minus b to the power 4. We can expand a minus b to the power 4 using the expansion of x plus y to the power 4, whose binomial coefficients I've written here. These are the binomial coefficients from the row numbered 4 in Pascal's triangle. Now, first note that a minus b to the power 4 is the same as a plus minus b to the power 4. So we can turn x plus y to the power 4 into a plus minus b to the power 4 by making the substitutions x goes to a and y goes to minus b. Now we've seen that x plus y to the 4 can be expanded using the coefficients from Pascal's triangle and the rule for the powers of x and y into this expression here, which is written in unsimplified form. When we make the substitutions x goes to a, y goes to minus b, this turns into this expression, where x has been replaced by a and y has been replaced with minus b wherever it occurs. And similarly, on the left-hand side, the x plus y to the 4 turns into a plus minus b to the power 4, which we know is exactly the same as what we actually want to expand, a minus b to the power 4. And finally, the expression on the right simplifies to a to the 4 minus 4a cubed b plus 6a squared b squared minus 4ab cubed plus b to the 4, where the even powers of b remain positive and the odd powers of b pick up a negative sign. Problem 3. Expand 2x plus 3y to the power 3. First note that with the substitutions x goes to 2x and y goes to 3y, x plus y cubed becomes 2x plus 3y cubed. So we can use the binomial expansion of x plus y cubed to generate the expansion for 2x plus 3y cubed. And the binomial coefficients for x plus y cubed are given here. The binomial expansion for x plus y cubed is 1x cubed y to the 0 plus 3x squared y to the 1 plus 3x1 y squared plus 1x to the 0 y cubed. And with the substitutions above, this becomes the following expression, where every instance of x has been replaced by 2x and every instance of y has been replaced by 3y. And we can expand this expression into 1 times 8x cubed times 1, where 2x all cubed expands to 8x cubed, and 3y to the 0 expands to 1, plus 3 times 4x squared times 3y, where 2x all squared expands to 4x squared, plus 3 times 2x times 9y squared, where 3y all squared expands to 9y squared, plus 1 times 1 times 27y cubed, where 2x to the 0 expands to 1, and 3y all cubed expands to 27y cubed. And finally, simplifying each term gives us 2x plus 3y cubed equals 8x cubed plus 36x squared y plus 54xy squared plus 27y cubed. Now usually with these binomial expansion problems we start at this point here, i.e. we do the substitutions that I explained explicitly here in our heads, and that's what I'm going to do in future problems. Problem 4. Expand 1 minus x to the power 5. For this, we require the binomial coefficients for the expansion of x plus y to the power 5, which I've written here. Note that 1 minus x to the power 5 equals 1 plus minus x to the power 5. So we can use the binomial expansion for x plus y to the power 5 to expand 1 minus x to the power 5 in the usual way. So we have a number of terms added together, each of which start with a binomial coefficient, 1, 5, 10, 10, 5, 1, multiplying 1 to some power and multiplying minus x to some power, where the powers of 1 and minus x add to give 5. 5 plus 0 is 5, 4 plus 1 is 5, and so on. And this expression simplifies to 1 minus 5x plus 10x squared minus 10x cubed plus 5x to the 4 minus x to the 5, where the odd powers of x gain a negative sign and the even powers of x remain positive. Problem 5. Expand a squared plus b cubed to the power 3. Following the pattern of the binomial expansion of x plus y cubed, we have a squared plus b cubed cubed equals 1 times a squared all cubed times b cubed to the power 0 plus 3 times a squared all squared times b cubed to the power 1 plus 3 times a squared to the power 1 times b cubed all squared plus 1 times a squared to the power 0 times b cubed all cubed, which expands to 1 times a to the power 6 times 1 plus 3 times a to the 4 times b cubed plus 3 times a squared times b to the 6 plus 1 times b to the 9, which finally simplifies to a to the 6 plus 3a to the 4 b cubed plus 3a squared b to the 6 plus b to the 9. Problem 6. Expand x plus 1 over x to the power 6. We expand x plus 1 over x to the 6 using the binomial coefficients from x plus y to the 6, which are shown here. Each term comprises a binomial coefficient multiplying x to some power and 1 over x to some power. So we can fill in this template as follows. And applying the powers to the brackets, we obtain this expression, which simplifies to this expression, which comprises only even powers of x, positive or negative even powers, and a constant term. Problem 7. Given that the first two terms of the binomial expansion of a plus bx to the power 4 are 256 plus 768x, find a and b. To begin, we need the binomial expansion of a plus bx to the power 4, but we only need the first two terms, so that's as far as we go. We have a plus bx to the power 4 is 1 times a to the power 4 times bx to the power 0 plus 4 times a cubed times bx to the power 1 plus, of course, the terms that we will not write down. And this simplifies to a to the power 4 plus 4a cubed bx plus the additional terms that we are not calculating. But from the information in the question, we know that the expansion must also equal 256 plus 768x plus the remainder of the terms that we're not considering. And from that, we can form two simultaneous equations, since we can equate a to the 4 to 256 and 4a cubed b to 768, since those terms must be equal for all values of x. So we now have two simultaneous equations. One, a to the 4 equals 256, which is trivial to solve by taking fourth powers on both sides, and we get a equals the fourth root of 256, which a calculator tells us is 4. And we can substitute the value of a equals 4 into 2 to give us 4a cubed b equals 768, turns into 4 times 4 cubed b equals 768. But 4 times 4 cubed is 4 to the power 4, which of course must be 256 from this equation. So we have 256b equals 768, and dividing by 256 tells us that b equals 3. So a equals 4 and b equals 3. Problem 8. Simplify root 2 plus root 3 all to the power 3. So we have root 2 plus root 3 cubed is 1 times root 2 to the power 3 times root 3 to the power 0 plus 3 times root 2 squared times root 3 to the power 1 plus 3 times root 2 to the power 1 times root 3 squared plus 1 times root 2 to the power 0 times root 3 to the power 3, which simplifies to 1 times 2 root 2 times 1 plus 3 times 2 times root 3 plus 3 times root 2 times 3 plus 1 times 1 times 3 root 3, which becomes 2 root 2 plus 6 root 3 plus 9 root 2 plus 3 root 3. And bringing together like terms, 2 root 2, 9 root 2, 6 root 3, 3 root 3, this becomes 11 root 2 plus 9 root 3.